If you are someone who has an interest in data science, then I think the topic of this video is going to be of interest to you. Hi, I'm Pamela Schultz, and I am a scientist delving into data science, and in particular, data visualization. And in this video, I'm going to update you on the progress that I've been making on the 30-day chart challenge. This is a challenge to make 30 graphs in 30 days. We're in the midst of it now during the month of April. And this is actually the 5th time the chart challenge has taken place. Only once before have I done all 30, so I'm hoping to do it again this time. And the way this works is that you can make whatever graph you like with whatever data set, whatever tools you like, but there are prompts along the way as well as themes. In this video, I'm going to update you on how I'm doing with the first theme, which I have completed, and I'm going to go through all the graphs. I won't talk about actually the first graph that I did because I already did a video on that one. And you can go to that one if you want to learn more about the chart challenge and see what I did. But I'm going to go over 5 graphs that I did for the next 5 days of the chart challenge. I will show you what I made. I'm going to talk a little bit about the techniques. This is not a step-by-step video, though I will show some aspects of what I did in DataGraph because that is the tool I use. If you are interested and you're a DataGraph user, you can go into the online examples. You can get all the files that I use to create these graphs. And if you don't have DataGraph and you're a macOS user and you're interested in data analysis and visualization, then get a trial. Go into the link of the video. That's where you can get a link to get a trial and try DataGraph out, and you can see if you can make some of these graphs for yourself. All right, so let's get started with day 2 of the 30-day chart challenge. Category for day 2, slope. Single word prompt. First time I did the chart challenge and I saw that prompt, I assumed this was the prompt to make some linear regressions on data and compare the slopes, maybe. But what I saw was a little different than that. Again, I come from a science and engineering background, but what people were making were actually graphs that are a slope type of graph. I know that now, and I'd like to show you a really great example of one. This is one that was posted by Alexandra Koo, and I love this graph. I think it is such a great example of a good use of a slope graph. You can see this is comparing grocery cart prices from 2024 to 2025 and comparing different types of grocery stores and how the price has changed. Great example. Well, there are a lot of examples of this type of graph that I have seen that I don't like. And in fact, when I first encountered this type of graph back in 2021, I made a post back then that illustrated some of the things that I don't like that people were doing. What I see often with this type of graph is that someone will pick a year and then another year, so 2 points along a trend line, and there may be a lot of years in between those 2 points, and just drawing a straight line between them is something I find a little unsatisfying. What I did back in 2021 is I used data on daily COVID deaths. This was very much on everyone's mind back then. This is data from Minnesota. And my point here was to show that if you took that trend line and just picked 2 points and you weren't showing me all the underlying data, I might not really understand what the trend was. So you could think, again, depending on the 2 points I pick here, that COVID's getting worse, COVID's getting better, maybe it never happened. The more revealing information to me would be to show the entire trend line. So I did a little bit of a commentary on this graph that I did for the 2021 chart challenge. So what did I do this time? Let me show you my graph that I came up with. Here I looked at data on slopes, skiing data, and I did not pick 2 separate points for the graph that I published. I actually did show the linear trend in the number of ski visits to different regions of the country. This is data that comes from the National Ski Association. And I made this graph, however, in two versions. If you download the file that I posted on the DataGraph online examples, you'll also see this version of the same data. Not the one I posted, but this is using this traditional slope graph technique or version that is, again, what I often see, which is picking one year and another year and drawing two lines between them. And the trends here are similar, but they're really not the same. If you look, for example, at the Midwest and the Southeast data, it really looks like these are going down quite a bit in the Midwest and maybe going up more in the Pacific West. But when I look at the entire set of data, and here I just did a linear fit line to each data set individually for each region, they look a little bit flat. Every region, that is, except for Rocky Mountain, which has a nice continuing slope that actually does sort of match the slope graph. But because we have, again, some extreme values on either end, on the left side and the right side of these other sets of data, I think doing the slope graph gives you a little bit of a missed understanding of what the trend in the data is. Now let's take a moment to see how I did this in DataGraph. Here is the DataGraph example window where, again, you now have this section for the 30-day chart challenge where you can see all the graphs that I'm creating. Here's day one, and here's the one we're going to focus on, day two. If you open this file, you're going to see not only the graph that I published, but you see, which is here, the final one, but you see a number of other graphs as well. The first one is a very traditional looking line graph where we also have a legend that shows you the color, which color is associated with which region of the country. The next graph is using the connect command to create this slope graph. This is a very, very handy command for creating a graph like this. In fact, for any of these, if you look behind them to see where the commands are and hover over a command icon, it will pop up and tell you which one it is. This is actually an error in our current version of DataGraph. It says lines command. This is not the lines command. This is the connect command. I promise. If you go under the draw menu from the toolbar, you see all these different commands. Here is the connect command, which has an icon that kind of even looks like a slope graph. And the third image that you see here is, again, basically the one that I put online. And this one is now formatted in terms of sizing and adding a little bit of cuteness with the skier icon. So let me just take a quick moment now to talk just a little bit more about how these lines are made. This is actually what the data set looks like that is creating this slope graph. Very simple data. I pulled out just the data from 1978 and the data from 2023 and the region name associated with each one. And the connect command itself that I'm using here, shown here. Now, if you ever want to confirm what each command is doing, you can use the hide functionality to confirm, yep, that's drawing these lines. And it has here the ability to specify basically x1, y1, and x2 and y2. This is where the lines are being drawn between. Let me actually just show you a new one so you can see how this is done because it's pretty easy. So if I want to add a connect command, in this case, I can actually type in where I want the first number to be. So 1978. This is one of these handy commands that you can not only use data from the data table, but I can type in values here. And then for my Y values, the first Y will be the column where I have 1978, and the second Y is the 2023. That's my slope graph. That was really easy to make. I can change the line thickness, and I can also have both the line width and the line color be dependent upon variables. And that's what I did in this graph. I can change the line color to be based on the region name. And then it's going to specify, well, what do you want to color with? And I already have a color scheme that I created. I'm going to select that color scheme. Here's this over in the variable section where you can see a color scheme that shows me what is the region and what is the color associated with that. That's how you can create the slope type graph with DataGraph using the connect command. Now, these other graphs that I made, The lines that you see here where I have all the data, these are using a different command. This one is labeled properly. This is the plots command, draws one or more line plots sharing the same domain. This is really quick and easy to make. So I'll go ahead and show this to you as well. This is using now all of the data. I can click on my first column, hold the Shift key, click the last column that I want to draw lines for, and I will go ahead and then add a plots command. Not every command has the ability to pre-select data like this. The connect command does not, but the plots does. So that makes it really easy to create all these lines. And to change the colors, Gear menu gives you a set of color suggestions. These are built-in colors that you can use. This is very handy. Now I've got my multicolored graph, and I can then go ahead and go up to the toolbar, add a legend. Boom. Now I have my legend. In the version that you see here, I've placed it to the right, but you have a lot of control as to where you place these legends. Now, this is a standard kind of a graph that you might see in a paper or a report. But if you can avoid making a legend, that's a good design choice. It's often recommended from a design perspective that if you can keep the label for the data with the data, it makes it easier for people reviewing your graphic to understand what is connected with what, rather than here I have to kind of look back and forth between the legend and the lines. So that's why in my version that I put online, I did not actually use this approach. There was enough separation between these lines that I felt like I didn't need to do that. So I'm going to actually do a Command Z to undo this and show you how can I take that approach where I customize the lines. And in fact, what I did in my final version again is this color scheme where I only colored the Rocky Mountain a different color. So if you open up the plots command, you'll see here is a sort of a built-in table that shows you each column that I am plotting against this X value here. And what I want to do is change the line color for all of these. I can do that up at the top, make them all nice and light blue. And if I want to change just the color for one of them, here's my Rocky Mountain. You can see the color tile here. I can change that from being same color, which is that color that I set up top, to some other color. This is a really handy way to have that kind of a design element where you use a different colored line for just one element as a way to highlight it. So that's all I have for day 2. Let's move on to day 3. Day 3, the prompt was circular. I decided to make what's called essentially a bubble graph where you have points that are scaled based on some variable. And here I ended up using the area that's associated with the Arctic sea ice in September, which is when it reaches a minimum. So there is actually an annual cycle to how large or small the areal extent is of the sea ice in the Arctic every year. But in September, it reaches its minimum, and that minimum has shrunk itself quite a bit. So compared to 1980, again, about 50% less Arctic sea ice aerially in the Arctic. So this data comes from the National Snow and Ice Data Center. This is a relatively simple type of a bubble chart here showing this. And let me show you a little bit about how I created it. Okay, let's open the file for day 3. And what you see here right off the bat is that there's a lot of data in this file. There's a lot more data than I actually needed to create the graph. This is data that's downloaded from again, the National Snow and Ice Data Center. There's the link to where you can get this data file. Very easy to load this into DataGraph. But you'll notice actually that I've also highlighted here, this is all the data in fact, I used for my graph, but I'm pulling this dynamically from my raw data set. Here is the graph that you see, again, the shrinking Arctic sea ice. But what I had to do first is I had to process all this data to get me to the point where I had the minimum data set that I needed. And so the way that I did this is I used what's called a mask in DataGraph. And every command within DataGraph that shows data has the ability to filter out based on attributes. And this graphic is actually filtering out the title here, the minimum extent at the beginning of each decade. This is using a command known as a pivot command. Pivot commands do all sorts of data processing. If you want to do anything in data processing with DataGraph, I really recommend learning more about the pivot command. You can always click on the gear menus here and go right to the help article associated with this command. It's created either from the toolbar or again from the draw menu here. Here it is, pivot. But if you want to open this up, if you want to look at this for a moment, you'll see that there is a section within this command, as in most commands that, or any command really that uses some data or has the ability to have data input, you'll see use as mask. And here I'm filtering out the year, or based on the year, the month, and the what I'm calling the year in decade. This is helping me to hone in on September. That's my month. I have a column here that I created, which is giving me the last digit in the year so that I can hone in on the beginning of each decade, 1980, 1990, 2000. And also I have I'm pulling just for 2024 because I didn't have all the data for 2025. Maybe I didn't actually need that because I also have the September. But anyway, this is the mask that I used for this, and it gets me to having this very simple set of data, which you can see here. And then anytime you use the pivot command, you can then go to the gear menu and then extract the pivot columns back into the data table, which is what I did here. Again, I just clicked on the gear menu, went to the extract option. That's how I got these columns that you see here, the year and then the minimum value. And that's what I used as input into my graph. So one of the things I really like about using DataGraph is this ability to dynamically sort the data. So if I have an updated data set that I can place in this file, everything in my graph would update and I wouldn't have to redo all that data processing. It would dynamically go through the pivot command and update these columns. And here within the commands that you see for the graph itself, this is where if you open up the points command, that's the one here that's drawing this, you'll see that it has this option for having the fill oh, actually, that's not the one. No, no, no. This is what I wanted to show you, even though it says fill. I'm not actually using that for anything. I'm not changing the fill color. All the fill is the same color. I think I experimented with the color scheme, but I didn't end up using it. The size here is what I'm using, the minimum value. It's just the same as what's being plotted, the year and the minimum. And I'm scaling that based on the area. There's a slider here that you can use to change what the size of the points is. And this is an easy way to create a bubble graph that is data driven and gives you this interesting effect where, again, the point size scales with the data. Day 4, category, big or small. Here, I decided to go for some Google Trends data. This can often be a great source of data when you're looking for something to plot, to compare different search terms and their popularity. And this turned out to be kind of a fun one to do, thinking about a tiny home. The term tiny house has become something that I think is part of our common vernacular. For many of us have heard of this before, this phenomena. And tiny homes, if you do a Google Trend search on it, then back in 2004, not a lot of people were looking up tiny homes, but there became an explosion in the interest in the tiny house movement, driven somewhat by different TV shows that featured tiny homes. I know that was how I was first introduced to the concept. And I compared that then to the search term McMansion, and the relative searches on this actually made this a kind of an interesting graphic. And I stylized this with a background of brick. I have a roof that I made uh, out of again, doing this all in DataGraph with using a noise in the background to give it a little bit of texture to it. So I was pretty happy with this. Now, one design element I did choose to use for this graph is I did change the color in the title in order to correspond to the lines. That is something I do very infrequently. I don't really like to use color for text unless I really feel as though it's useful and can easily be tracked to what does it correspond to, because often colors in text can make text harder to read. But here with the bright blueberry and the red, I thought this was actually a good way to encode the lines to let you know what they corresponded to. Okay, let's see just a little bit about how I made this. Okay, let's go ahead and open day 4. When you do, you're going to see the graph that I created here, the graphic that I just showed you, and then just a basic line graph. How did I start making this? Well, this is what I started with. Now, a couple of things to be aware of. Let's go ahead and just show you really quickly how you could try and recreate what I did. I'm going to hold my Shift key and select the data, and rather than the plots command that I showed you earlier, which is really good when you have kind of a big matrix of data, I often just use the simple plot command. So I can actually just click this once and then twice, makes my line plots. A couple of things though, when I make graphs like this that have this kind of design element, I often like to make my lines thicker than I would normally do, say for a publication. And you'll notice that I'm getting these spiky edges. This is uh, something only that happens with noisy data when you make the lines thick. So if I go into the options for my plot command, there's an option for line join. You can change that from miter to either bevel or round, and then you won't have that happen with your noisy data set. Again, if your line thickness is not that big, you wouldn't really make it this big for a publication, you're not going to see this problem, but it's a good thing to be aware of. Other thing that you might note here that I'm going to click and zoom in on a little region of this graph, there are some breaks in the data just for McMansion. And that's because the search popularity was so low that it just says negative, not negative, less than 1 in my data table. Rather than kind of mess with the data, I could have, I guess, done a find and replace. I decided here to just do what we call bridging the gaps in the data. So let me make the line a little thicker here so you can see this too. And if I just check that box, anywhere where you have missing data, it will just draw a line in between the 2 points, in between those missing points. It's a handy thing to be aware of. So that's how I started with the line graphs. The other thing that I think is really kind of a nice design element here that I'll point out to you, and let me swap my layout. Oh, whoops, let me pull this down a little bit so it lets me do that. View, swap layout. Now I can really see all my different commands that I have here. So this one is actually a picture of a brick wall that I brought into DataGraph. And all I had to do was drag and drop that image right into the command list. It creates a graphic command. And now it's something that I can scale it in different sizes. I also have this actually clipped with a region. So this is a really, really handy thing to be aware of, that you can crop an image actually dynamically, right? In fact, within the graphic command, that's not what I did. Instead, I find it handy to, or in addition, I find it really handy to use this clipping with functionality where I can have another command. The one here is a region command. This is just drawing a triangle that is the minimum and maximum X and Y values within my graph. I'm not actually drawing this. You'll see it's actually excluded from view. If I uncheck this and just show you, yep, here's where this rectangle is. You can see that. And that is what I'm using to clip this image. So if I take the clipping away, you'll see the whole brick wall there. Since I wanted to keep it just within my graph region, I go ahead and clip that. And again, I don't need to see this. I'm just using that as part of my ability to clip this exactly where I want it to be. Anyway, it's something that I find, I thought that was kind of a nice design element here. Let's move on to the next day. For this day, the theme or the prompt is rankings, or was rankings. What I decided to do is to animate the top 10 NCAA rankings end of season rankings for the men's basketball team, highlighting teams here in North Carolina. I'm in Chapel Hill, North Carolina. I went to UNC, so I am a Tar Heel, and those are the teams, or as well as NC State, Duke, UNC, NC State. I chose to highlight those with the colors that you can see here. And this is starting in 2005, but let me show you what happens when I animate this. And I thought it was just really interesting to see that in 17 of the past 20 years, at least one of these teams was always in the top 10. And uh, in many cases, you'll see both UNC and Duke and NC State also makes an appearance in the top 10. Uh, there it is, NC State. So this was sort of a fun graph to make. I will say we began the animation with North Carolina ranked at number one at the end of the season, and we ended with Duke ranked at number one at the end of the season. In any case, I still think this was a fun one to make, interesting data set. So let me show you a little bit how I made this animation. Here's the day 5 file. Go ahead and open this up. And I'm not going to lie, this was a little bit tricky to make. We have some other files in our example files that have if you go to the online examples, there is a bar chart uh, race example is the one I'm trying to find here. And here it is. This is, if you're interested in these kind of graphs, the bar chart race example is a little bit easier to create than what I did here, partly because of the way that this data was set up, in that if you look at the raw data that I downloaded, the top 10 teams don't always have the same teams. So I couldn't do a normal interpolation of this. I had to kind of pull the data out, create a table that had just the teams, and I'm using some of the mapping tools within DataGraph to get the rank for the current year, the rank for the next year, and then I interpolate between the two to figure out how to move the bar from one year to the next. So it took me a little time actually to get this working the right way, but it was kind of a fun little challenge to figure out how to take this data and animate it. And if you want to just come into this file and run an animation, the animation variable is down here at the bottom left-hand corner. You can see here's an animation variable called T. That's what it's called by default. You can change it to whatever you want. You can see the range that I'm animating here. And if you want to run the animation, then hit the play button, and then the graph will start to animate. So the other thing I had to do here was the animation variable is continuous, but I wanted my animated portion to have a pause in between so that you had a moment to see where those bars were. Otherwise, it was just way too jumpy going from one year to the next. In any case, that's what I came up with. And animations are very fun to do within DataGraph. And the key to creating them is to figure out how to manipulate this animation variable within other expressions or variables or or equations to essentially just have a plot move and have the elements of the plot move throughout. So here, for example, this really is just a basic bar graph. This is using a bar command. That's the command right here. It also lets me have this color scheme associated with the different bars, and um, and it's just using this column that's going to change as it goes. So again, it's these two columns here, the rank animate and the wins column, that these columns are changing and therefore the graph is changing. Here we are to the last graph that I did for the theme of comparison for the 30-day chart challenge. This is day 6. And day 6 was a theme day, Florence Nightingale. And in the past, I had recreated some of really probably the most famous graphs that Florence Nightingale did, the rose diagrams. But Florence Nightingale did a lot of graphing. I actually wanted to put in a little bit of a plug for a book that I got. This was published in 2022. Love the quote that's in the beginning. Whenever I'm frustrated, I revenge myself with a new diagram. This is a woman after my own heart, Florence Nightingale. This is a beautiful tribute to her. I love this book from Visionary Press. You'll notice actually the rows diagram on the front here. But what I decided to do here is actually a comparison between the rows diagrams and just doing a basic bar chart. Because as much as I love the elegance of the rows diagram, there's something to be said for whether or not it is always the best way to show data and reflect data. So here I'm comparing, this is the same data shown in these rows diagrams as I'm showing down here below. And in some ways, I feel like it's a little bit easier to explain using my bar graph here. So what I have is data. This is from 1854 to 1856, monthly data on mortality and the causes of mortality in the Crimean War. And Florence Nightingale actually arrived somewhere around October of 1854. And when she arrived, she observed the fact that there were a lot of unsanitary conditions and was advocating for sanitary conditions to be implemented. Uh, when that was implemented, that was here in uh, March of 1855, or at the end of March of 1855, they saw a dramatic decrease in the mortality uh, that occurred on the soldiers that they were treating during the Crimean War. And she made these graphics to illustrate that and promote the fact that sanitation was really important. However, I guess I'm asking the question, which do you think is a better way to represent this? The rows diagrams above, which also show a petal for each month, and we have the before sanitary commission and the after sanitary commission compared to the standard bar graph. Which one do you prefer? All right, let me show you a little bit about how I made this. Okay, we're coming to the home stretch here where I want to just show you a little bit about the file itself that I used for creating that graphic. But before I open the day 6 file, I just wanted to let you know that if you go into datasets, there is a file here that we have with the Nightingale rows diagrams. And if we go ahead and open this, I did update this file in addition to creating the other file that has some repeated data and information. But in any case, I started with this file when I created the other file. And as happens sometimes when I open older files, I realize, there's some better ways to do things. So this file is something that I improved. I found that, it has this data set here where you can see the date and you have the year and the data on mortality for disease and wounds and other. And what I needed to do was separate that out into two sections, one section for the first year, one section for the second year. And I did this here now using a mask column, which I think made it, in my mind, clearer as to what this data was, because for making the pie charts, the pie command, if you mask rows of data with the pie command, it just will hide those slices. Thinking about if we should have an option for just excluding those slices that are masked. But in any case, it means that when you make a pie command, you have to isolate that data that you want to include. And that's how I'm making these rows diagrams. If you want to see some of the commands, let's go into one of these rows diagrams to look at how these are made. This is just a series of pie commands. Let me actually just collapse these down and open them back up again. There, so you can see now these different wedges. If you want to hide them, this is just overlaying each wedge one on top of another. And I did find I wasn't computing my distances exactly properly. So that was one of the things I also fixed, because the distance itself really has to be scaled, or the distance that you calculate, the scaling on the area has to come from the center all the way out. And I had had a little bit of an error in how I was computing those before. So now I am in better agreement with the original graphs in terms of how Florence Nightingale made them. And in any case, I was pretty happy with how these came out. And if you want to see the details of how that is calculated, then you can look at these A, B, and C columns. This is how the values are being scaled properly in order to create those wedges. So with that, the final graph that I made is really just pulling together as graphic commands all of these images that are created in separate graphs. This is also really easy to do in DataGraph if you want to compose a bunch of separate graphs together, make a new one, and then you can just drag and drop different elements to bring them in and use the functionality within DataGraph to either drag them around, or you can change where you want to anchor the graphs. In any case, that's what I essentially did here when I combined all these graphs together. And oops, actually, I meant to show you my other file as well. Where is my, I must be getting tired now. The example file window, where did I go? There it is, example files. Okay, so in my, I forgot that I wasn't in my final version. So in the 30-day chart challenge version, if you wanted to open that one up, that's where, again, I have these same thing. It's composed together into one file with some text elements added. I changed the text to be also use a text variable here. This is Great Victorian Standard because Florence Nightingale was a woman of the Victorian era. So this seemed like an appropriate font for this, even though I sometimes find this a little harder to read than the standard fonts that I tend to use in graphs. But in any case, I think it looks rather elegant. And lastly, with this one, I'll leave you again with this question. Which do you prefer? The data shown as the rows diagrams or the data shown as the standard bar graph? Thanks so much for watching. You've made it through these first 6 graphs with me. Subscribe to our channel if you want to keep up with when I do my next video on the next set of graphs. The next topic or the theme for the next 6 graphs is distributions. I've already started making some of those and I have a few more to make. But with that, of course, if you have any questions, you want to see more detail on how I made any of these graphs, then please let me know. You can contact us, actually contact me via the Visual Data Tools helpline, help@visualdatatools.com, or leave a message in the chat. And don't forget to like and subscribe.